And we are live. I think we are live. Let's greet the chat, even though no one is here. Your channel. Oh, we are live, guys. Fantastic. Yes, that's me. Yeah, definitely me. Happier times. I'm sorry for like the 2 days of not streaming, even though no one is here, so no one cares, but life happens and I had to do things. We left off on this note. I read like the code base. I went through the code base one more time after I stopped streaming, and the problem is the usual thing. The problem was that the linear was working, so the mouse dump mode, you have the linear was working and should be working, right? Should be working, yeah. The quadratic was not working at all, because it's incredibly slow, as you can see here. I don't know if you see it, but it's like it starts from 1, 0.99, 0.96, 95, 94. Like it's incredibly slow. So the idea is to fix them. And why? What's the problem? Well, the problem, truth to be told, is the fact that these actually translated to like this thing right here, which was basically this, translated to a function like this, or better, a function like this, in more general terms, s minus s times the d times it would be t k minus 1 minus t0. T0 is the time at the start of the wheel event. Okay. Tk minus 1 is like the current. It's the time at the start of the k minus 1 frame. Here we are computing the wheel value for the kth frame. Okay. So graphing calculator. The thing is that a function like this is basically s minus s d. Let's call this difference x. Okay, let's call it x, which is basically the time from wheel event. Okay, so that's the thingy, and it is that, let's suppose this is 1. Look at the damping factor. It's a linear kind of way, obviously not negative, please. So it's something like this. Now this is the linear, not very like impressive, but we can also have the quadratic. We have to basically square not only the x, which is time squared, but also the percentage per second. So the idea is that we have the squared, and we said, okay, so we can simply update our VK. We can update our VK okay, like this. Vk s minus, sorry, vk would be vk minus 1, vk minus 1 minus the start times the damping factor squared times the delta k minus 1 squared. But the problem is that it's not, okay, allow me to abuse some notation, it's not vk equals s minus the start times the damping factor squared times the x squared. It's not the same, okay? So that's the problem. Another thing that I to recap what we did last stream, where we left off in our last stream. Another thing is that, okay, we not only can have a quadratic but also a square root. Okay, so I would love to have both, like all three. So here the mouse damp mode, linear, quadratic, root, and obviously I would love to do something like that, square root to be implemented. So we need our x, and our x, we said, is this right here. It's what we want. So we need to register, we want the current time in seconds, okay, and we need the time in which the wheel event started, basically. Now our wheel on wheel start time in seconds. Wheel start on wheel start time in seconds. Okay. So how do we do it? Well, we simply have fun and say we keep abstract. Uptime data, and with the uptime data we say the we have the frame begin timestamp. We have the frame end. We have begin end. We have the float second since start, seconds since start, or we could say like since start, okay, seconds since start. We also have the float frame delta time in seconds, seconds. So up time in seconds, number of seconds since the start since the apps start. Float up frame delta time in seconds, in milliseconds. Frame, okay, let's call it easy. Frame start, frame end, timestamp collected at the start of the frame, at the end of the frame. Frame delta time in seconds would be, well, time it took the time it took, time taken by the last frame, time taken to process the time taken by the last frame in seconds, and here it's just the time taken by the last frame in milliseconds. This is the number of seconds since the app start. Fantastic. So uptime data, Amazon is initialized here. Let's call uptime data m time data. In the app, say m time data. Oops. And okay. Here we also struct up FPS data. Okay. Float frame FPS for the last frame for now. Okay, then we'll have other things. Up FPS data, so here we put up FPS data and FPS data, and the MFPS data, then we also need to initialize it here. Okay, so M time data dot frame start is this. Delta time in seconds. Okay. Frame delta time in seconds. And time data dot frame delta time in seconds. Okay. Okay, so time data dot frame end. Here is frame start, frame end, this frame delta time in milliseconds, which is the frame multiplied by 1000, and then here we have the m fps data dot frame fps, and we got it. Everything should work fine. Obviously no. Why? The UI jump. The UI frame, so let's call it time and frame time data. Let's call it time data here, and frame data here. Time and frame data and FPS data. So let's just pretend. Let's just up frame up. So we just Babin. Now so so the frame delta time in seconds. So first and foremost, we have the up time and data dot up time in seconds, and this is the up time in seconds. Then we have the frame delta time in seconds. Then we have the frame delta time in milliseconds, something like that. And then we have the frame FPS, which is m FPS data. Little crazy. Let's go. So we can see. Let's put it like this. So the up time in seconds is wrong. The frame FPS, okay. The frame delta time in seconds is very small. Well, this is a problem with the printing actually. So let's say 2, 5, 2, let's say. Okay, so it's good enough. Now, this thing right here, the problem is that we never update it. So obviously we need to do it. How? First of all, uptime check. Fantastic. beautiful. So let's do a commit. Let's say keep track of make struct for both timing and frame data, and keep it as a member of app class, of the app class. The L sometimes gets messed up a bit. Let's push. Let's do it again. Okay, very interesting. Okay, so now obviously the problem persists because we did nothing about it, but the solution is very interesting because when so we need in our mouse the wheel row value, okay, with virtual start, the wheel virtual, but we also need the last wheel event time in seconds. Okay, last wheel event time, last wheel event time in seconds. Okay, and we pass it here. Last wheel event, so current up time second. Current time in seconds. Okay, obviously we put it right here. We do something like this, and with virtual good. Now when we do the update, we don't pass the delta t, the delta time in seconds. We pass the current uptime in seconds. Current uptime in seconds. Let's do a float. Time from will start. So our x, let's call it x, it's the time from sorry, oops, time from will start, in seconds. It's the current uptime in seconds minus the last will time from will start time from last will event in seconds. Okay, so the time from the last wheel event in seconds. Fantastic. Let's call it x, and then we say the wheel virtual, so with the linear, our virtual wheel is the start minus the start again times the damping factor times the x. Okay, now now the wheel dump squared the idea is that in the case of a quadratic thingy, we do the start, we subtract it from the start, multiplied by what? By the damping factor, so float wheel damp squared, which is just the config with damp times the config with damp float x squared, take the x and we square it. So we have the wheel damp squared times the x squared. Things should work. No, they don't, obviously, because in the set wheel we pass the delta, but we also need to pass m up, so m time data dot uptime in seconds, current uptime in seconds, we will current uptime in seconds. We do it again, the mouse.up, when we call the update, when is, can I find our references, shift F12, okay, nope, yes, we call the delta time. This is wrong, very, very wrong. We don't want the delta time. So let's do something like this. New frame. We compile. Something will be wrong. Here. When we pass the new frame, we need the m time data dot. Okay. So now we need the m time data dot the uptime in seconds, and this is when we call the new frame, we need the float. This is the current uptime in seconds. Pass the new frame. Okay, so we did a refactor, this little trick. Something went wrong. Oh, obviously, current uptime in seconds. What do we need here? The current uptime in seconds. We compile and everything. Possible loss of data. Oh, because the wheel events are wrong. As of right now, let's do a rebuild. Okay, let's try it. So this is the okay, so mouse dump mode quadratic, and the mouse dump mode this is the quadratic dump mode. Okay, let's try the linear dump mode. I think is slightly the quadratic. Oh yeah, has a slower, like smoother on the it's faster on the start and slower on the end. Let's try the square root. Obviously it won't work. Oh, okay, so it's just the wheel multiplier, it's basically the same. Okay. Okay. So the idea is that we just this is will so this is float will dump sqrt std sqrt config with them. Oh well, I could write it like this. Std sqrt with them times the x. So it's the start minus start times the square root of the dump times x. I could write it std or I should put the base. Yeah, let's keep it like that. I don't care. If I do so, it's slower. Because I also square rooted the damping factor. Okay, let's try the quadratic. It looks kinda good. Okay, so we are done basically. There is only one thing missing, which is discussing the conservation of momentum when doing the update, meaning when setting the wheel. So instead of just setting the wheel row to the row value, why not instead of setting the wheel virtual basically instead of setting the virtual to the virtual start, why not taking over virtual and summing to it the virtual start. Obviously the virtual start will be updated accordingly to the new So basically, if you go in the same direction, if you scroll in the same direction, okay, you accumulate momentum. Okay, instead of reducing it like so, you should be able to accumulate momentum instead of being kept. Okay. If you obviously change direction, you should be able to do it like snappily, so you just don't conserve momentum in that scenario. Okay, that's it for now. I hope I'll be able to stream later today, this afternoon, and see you later, possibly. Oh well, wait, first before signing off, I want to commit. So implement quadratic, so fix quadratic and square root dumping mods commit. That's it. Oops. To do broken. No, it's not broken anymore. Remove to do. Yeah. Okay. Bye bye.